Now let's take a look here at example number 2. In this example, I want you to try to find some explicit formulas for each of the given sequences that have their first few terms shown here. Now I'm going to go ahead and label this first one as A sub n, meaning I'm going to call this list up here A. I'll call this list down here B, and my last list C. And I want you to see if you can go ahead and try to come up again with an explicit formula. That means when I plug in 1, I generate a number 1, 2 generates a number of 8, plugging in 3 generates a number of 27. If you'd like to instead imagine starting at n is equal to 0, you can do that as well, and I'll write down both of those sorts of answers in my solutions. But I'd ask you to go ahead quickly, pause the video, and just try to experiment a little bit, have some fun, try to figure out what formulas you might be able to come up with here, and then you can hit unpause to see me go through the solution. Okay, so one solution that I might have for this first one is n to the third power. Notice again, this assumes that n starts at the number 1. And so I have 1 to the third, 2 to the third, 3 to the third, 4 to the third, and 5 to the third. Notice this isn't the only possible formula that I could come up with. Notice if I wanted to, I could come up with a formula that looks like this and specify that n is going to start with numbers 0 and then the number 0 and then go up from there. This would generate the exact same thing. Down here on part B, I could actually come up with a formula that looks like the following. Notice that if I added 1 to all of the numbers that are listed here, they all look like powers of 2. So this is like 2 to the first power, just take away 1. That's 2 squared, just take away 1. And so this would be a formula that could generate those numbers in that order. When I look at C sub n, I'll notice this is actually also a really easy one to come up with. The numbers in the bottoms of these fractions always represent the spot in which I'm currently positioned. So I have something like 1 over 1, then 1 over 2, and 1 over 3, so on. And to get this alternating negative 1 and positive 1 in the numerator, I can just take negative 1 and raise it to a power. Now, this isn't maybe the right power yet, because you'll notice if I plug in 1 in my first spot, I'm going to get a negative 1, and I want a positive. But I can go ahead and just quickly adjust that by maybe adding 1 to that exponent. So this here would be something that would generate exactly the numbers in that list in that order. Again, this isn't the only possible way you could write this. If you were planning on starting again n at the value of 0, you could probably go ahead and write down a formula that looked something more like this. It's just important to remember that anytime I'm not starting at the value of 1, I must specify where I'm starting from. So over here, since nothing's written down on where I'm starting, it's a class agreement or assumption that we will be starting at the value of 1. And that's what we want to keep in mind.